All right, so we know a bunch of cool stuff about classes, now how to make them. What they originated from structs. We turned them into classes. We gave them data plus operations. We already had the data from structs. We learned how to make nice-looking classes, implement things outside. We know how to set our member variables now. So I'd like to come full circle now. We can recreate that example of that little counting device. I made it using classes at the start of the semester. You understand everything now, and we can do it the right way. Right? So let's recreate our counter library. We also did that too, right? We made a little library using just functions. And this gave us one counter that we could increment and decrement. Let's make a counter class, right? So we can make a million counters and like click them all. Doesn't matter, okay? So what do we want in our counter class is now the question. We'd like to make a class called counter so I can declare counter, like counter C or something. And then here are like the same operations that we would like to have in our counter class, the same ones that we had in our little library. So like every counter, I want to be able to initialize it, like make sure that its member variable inside of it starts out 0 because at the beginning it's garbage, right? Like every counter C here is kind of what I want to be able to do to it. Like it better have a count. Starts at garbage. We need to like call our init method on it to start out at 0, right? It's a little unfortunate. And I want to be able to like increment it, like have that ability. I want to be able to decrement it as well. So init as well. Init at the start, then increment, then decrement. All these operations should exist, all right? And plenty more. We want to be able to like get the count back. There's a reset function that we had. We can translate that into a reset method, give it a new count maybe, reset it straight to 42. But then like when you call c.inc, it should increment that counter's count from 0 to 1, and so something like that. And we can have a bunch of counter variables, counter D, counter E, counter F, not just one like we were kind of forced to have with this library of functions, all right? So let's make that happen. Let's implement that, okay? And then we'll make it better and better, slowly but surely, all right? So I'll call this and kind of here's how I want to use it, right? I want to be able to say counter C, C dot init, and then like inc it a few times, 3 times. Now the counters count. We should have like a get count, right? A nice getter. C dot get count should give back 3, yeah. And then we should be able to decrement it as well. C dot dec, oops, there. Decrement it a few times, and now the counter's count should have gone down to 2 and now to 1. We should see 1 printed out. We can turn these into tests eventually too. Something like that. That's a good start at least. And then I also want like a reset method. I guess we can do that too. Like reset to some new count. Like all right, c dot reset yourself. Reset the counter in your window. Like turn the little dial to make it 42 instead of whatever it currently is. And then I don't know, increment it one more time, and now that's how I want to use this counter object and this counter class. And you can make as many as you'd like, of course. But yeah, that'll be that. So let's make it now. Class counter. And all right, we got some public stuff. I got some private stuff. Private member variable, what lives inside of every counter is a count, bless you. And it'll just be an int, right? Int count. And we don't want the user to have access to that. We're going to control access to that. It's going to be private. And then we would like all of our operations, all these guys. Those can be public. The user gets to see those and use them. Right? So let's make these normal looking. So init is just meant to be called in a line by itself, so it's a void method. Void reset, give it some new count, int new count, void int. Deck. These are all just meant to be called online by themselves, and then get count finally gives back our current count as an int. All right. So we got all those. Which of these should be const? You remember? Which of these should not be allowed to touch the member variable, which is just count for us? Good. Yeah, our getter. Our getter is just meant to come and look at our count member variable, not ever change it. So that should totally be const. The rest of these are messing with count, aren't they? So we're going to need them to not be const, I guess. So yeah, let's go and implement these now. So this is not an init function, it's the counter class's init method. Right? I've got to tell C++ this is not a function, it's a method implementation when you do it outside like that. So let's just give these some empty bodies to start, and then we'll implement them. Oops, wrong kind of thing. There we go. All right, one by one. So counter's init, it's just supposed to make sure our count isn't garbage, make it 0 at the start, right? Well, we should always remember to call init before we do anything. So that's just supposed to set our count to 0, initialize it. That's pretty easy, right? And then reset is kind of similar, but it's like you give me some count that you would like to set into our counter variable, like turn the dial and make the count exactly that. That should also change the count to whatever new count is, like 42. Increment should increment our counter member variable, our count member variable. Decrement should do the opposite, count minus minus. And then finally get count, go in, look at the count member variable, give that back to the user. They just get to look at it, all right? So that's going to be return count. Okay, so all those bad boys work together. Those are their implementations, and here I am using them down in main. All right, so in theory, this zeroes it out. 1, 2, 3, prints 3, 2, 1, prints 1, so that's a count to 42. Make it 43, prints 43. So I should see what? 3, 1, 43? Yay, and I do. All right. So yeah, those are the first pieces of a nice counter class. Any questions about that? Yeah. That makes it so that you, in this method's implementation, you can't do something silly like change a member variable. You cannot touch your object. Can't be like, all right. It can only read it now. Yeah, so you can't do something silly. It keeps you from making a mistake like that. Yeah. So that's why we like it, because we don't trust ourselves. Just like we don't trust the user. That's why we have private as well. So we don't trust anybody in computer science. Yeah, any other questions? So I want to make this a little bit fancier, right? Before we get there, though, I do want to kind of talk about like what's happening under the hood. I try to draw it like this at the start. Like every object gets their own version of init, inc, and dec that's just messing with their own count. But honestly, that's very inefficient deep down. Like what's really going on deep down is that every method that you make, it's actually just a function as far as C++ is concerned. It's just a special kind of function. Like C++ does it nicely. Like when we use the syntax, it does cool stuff. But secretly, when you call a method, what's happening is there's a secret 0th parameter, and that's the name of the object itself. So every time you say c.inc in C++, it's secretly being translated into this. It's really just a function call. It's a call to counter ::inc, right? And even though inc took nothing, it secretly does take something always. Every method call takes the object itself, all right? That's the secret. So every time you do this and use object-oriented programming, it's really being turned into a call to this because the compiler only needs to make just like one inc, not an inc per object. So that saves space. That's secretly what's going on. You don't have to worry about that. It's just, if you wanted to know, now you know. Okay? So that also means, that also kind of gives you a way, like that's how the method knows which object to touch as well. We call this secret 0th parameter. It's a pointer to yourself. It's whatever this current object is that you're working on. So it's called this, and that's actually a keyword in C++ that you might read about one day. And so like whenever you say like counter inc, c.inc, it does jump up here to, well here, I can do it over here. It does jump up here to the body of the inc method, and secretly you got the counter called this deep down inside, right? It's secretly called this. And so here, this count plus plus, it's really in the body. You say count plus plus, it's really being turned into like this dot count plus plus. All right, I know those t's and pluses look the same, but that's the idea. Curly t maybe. There. So that's, if you wanted to know, if you care, like this is a very interesting idea. All right, secretly, classes are just fancy functions under the hood. All right, so here's what was going on. In main, we had a counter called C. Its count was 0 at the start, right? And then we called c.inc, right? The very first time when the count was 0. So really it was called a counter : inc, kind of like a function with a secret 0th parameter called this that took the object itself. So counter : inc with some of this parameter. And your C, right, got shoved into there. Okay, so that's your secret 0th parameter. Every method call works like this. It just gets shoved at the start of the secret 0th parameter. And so that's why, like, that's how you're getting the C, and it knows to touch C's count. It's like it's really being passed along into a variable, always. All right. That is the trick. That is the secret. And now you know. So every time we called something, it's really just a function call. Same with reset. Even though it takes something, it's really C. It's really counter : reset with C and then 42. There's really 2 parameters for that function, 2 arguments being given. All right. So that's how it knows how to touch the object. It's actually being passed the object. Okay. So like this is always. It's like another spot for a parameter in a sense. It's an argument secretly. But yeah, I'm not going to like test you on that idea. But one day you will take a compilers class at a 4-year college. If you're a science major, you will learn how to make compilers. You might have to learn how to compile classes deep down. It's really just a bunch of function calls, right? So that's the secret. You don't have to worry about it in this class, but you've at least heard these words now once. So it won't be magic. Less magical now, all right? Yeah, question? Yeah, it just looked like another plus. I was trying to help you as you were reading it. Yeah, it's like this looks like 3 pluses. It's really a T. Just count plus plus. That's my idea. All right. Okay. One thing I don't like about our current counter class is that we have to remember to call init, because otherwise count is garbage. You can't just immediately call inc on a counter C. Like if you didn't have this line, you're incrementing garbage right now. Yeah, we don't like that. Wouldn't it be nice if there was a way, really? Wouldn't it be nice if there was a way to always call init and never forget? I think we're on board with that. So that's called a constructor. All right, we would like to have this. It's like, what if you forget to call init? You're in trouble. All right, C++ gives you a way to never ever forget. It's called a constructor. All right, a constructor is just a fancy method, just another method with a special name, and it gets called for you the second you make an object. So like on this line, it will call this thing called a constructor if we make one. So we can't forget, because that's when the whole thing gets made in the beginning. Right? So it's just going to do it for us. So a constructor, it's a special method, and its name is the name of your class. So if you make a counter class, your constructor will be called counter. Right? You can have multiple constructors, but it's called counter. There's also no return type. That's kind of redundant. It's like it's returning the name of the class. It's returning that type already. It's like counter. There's no use saying it twice. So there's also no return type, which is called counter. And it can take arguments. It doesn't have to take arguments. All right, I'll show you how to call it with arguments in a second. Like it's obvious that the return type is unnecessary, and you can have as many as you want, and they can take different kinds of parameters just like other methods could. All right, so the special constructor that takes no parameters is called a default constructor. Right? So that's this one. Something called counter, a method in the counter class with the same name, so it's also called counter. Takes nothing at all. That's called your default constructor. All right, and that's the one that's going to run on this line because we're not giving any arguments or anything. So this will call the default constructor, just declaring a counter. It's going to make memory for it and then also call the default constructor if we have one. And we're about to make one. So let's make a default constructor and then one that takes a parameter as well. All right, so you can make constructors that take stuff, and I'll show you how to give it stuff. Because like, if it happens on this line, like how do you give it parameters? So here, all right, we don't need it anymore if we do it this way. I'm getting rid of it unnecessary now. So I'm going to make some constructors. All right, and I'm going to say it's just called. I'm going to declare them and then implement them outside. So it's just counter open paren close paren for the default constructor. Now let's do that one first. All right, so I'll implement it in just a second, but this is the line where the default constructor will get called. All right, it's going to get called for us the second we make our object. And so this line calls the default constructor now that we have one. All right, which is very nice. We can't ever forget to initialize now. It's just like always going to happen. So let's give meaning to our constructor now. Let's give it an implementation. I guess if I'm declaring it up at the top, maybe I'll implement it up at the top as well. So it looks a little different to normal methods though, because it has no return type. It's counter colon colon counter, and then you're off. All right, because it's returning a counter in a sense. Okay, so this is the default constructor. What do we want to do? Well, we can just like exclaim that we're in the default constructor. We print it out just to prove to ourselves that it's really being called. I'm in the default constructor. Yay. New line. And like, what do we want to do always to initialize our counters? Just like set the count to 0. All right. That's a good default construction idea. All right. So again, down here in main, just you making a counter and saying semicolon calls the default constructor. It's going to jump up to here and do the initialization. Isn't that nice? That's super handy. And oops, what have I done wrong? Did I spell it wrong? Oh, I still used init. Did I not save the file? Oh, I implemented it still. That's my bad. So we don't have init anymore. Sorry. There we go. Now it's happy. We don't need init. Cool. And so right at the very beginning, this line gets run, like it makes memory for the counter C, and it also calls the default constructor. Declared right there. Implemented right there. It's going to print out stuff, set it to 0, and so all my inks and everything, like it still works as normal. So now we can never forget to initialize stuff if we make a constructor. That's very nice. That's super, super nice. All right, let's also make a one parameter constructor. So another thing called counter that'll take something. All right, let's give it what's another way that we could possibly want to initialize our counter? Maybe with some other count than 0. So let's have the user pass along like, what count do you want? Like int starting count, something like that. Yeah, that's called a parameterized constructor because it takes a parameter. Parameterized constructor, and we can implement that. So again, what's its name? It's counter colon colon counter, special name, and what does it do? Does some sort of initialization. All right. So we can say that I'm in the parameterized constructor this time. And obviously this is not the right implementation anymore. It should be like set the count to the starting count, initialize it that way. That's another way to do it. All right. So that is another kind of constructor. We can call it. All right. Let's call it down in main, and here's how. We have to pass something on this very first line. We have to pass an argument. So that one's calling the default one. Here's one that's calling the parameterized one. So let's do counter D. If I just set a semicolon, that would hit the default constructor again because I gave nothing. All right. So I want to hit the parameterized constructor, so I need to pass along what it's expecting. Parameterized constructor wants an int. Right? So here's where I put it. You like kind of call the name of the variable as a function in a sense, as a method. So 33. That's where you do it. That's going to hit. So like, okay, you're making the counter and you're passing something, so that means you wanted to call this constructor. That's that one. And now it works as normal. It's been initialized. The count of D is, inside of D is 33. We can increment it, d.inc. And then we can print d.getCount. Right? So that should see 34. And then also we'll like shout out that we're in the parameterized constructor because this call is really making a constructor call. It's always initializing stuff for us, one way or another. And so there's my 34. All right? So that's very, very powerful and a really good idea. I'm glad that we have that. All right? Are there any questions about that idea of a constructor? Just a way that you can never forget to initialize yourself. It's going to get called if you make one. The default one gets called if you don't say anything, just like normal, semicolon. But if you give something, that'll call one of the other ones, like the one that expected that thing, that int. Okay? And again, here are their implementations. Very, very useful things. Question? Because that's the parameter. So I'm giving 33 here. I need to give it a name, just like any other method. Okay? 33 is going to go into starting count, and that's what I'm going to use to to initialize my count member variable to 33. Yeah. All right. If we're good, there's one other thing that I could do a little bit better. So let me teach it to you. You have to know it for certain things anyway. So this is great. We love constructors. There's one extra thing. There's one extra piece of syntax you can use inside of a constructor that's new. It's called an initializer list. Okay. And so let's say, just for sake of argument, that you had more than just a normal int as your member variable. You had, let's say, a vector. Why not? It kind of doesn't make sense for a counter to hold a vector, but like you can imagine you might make a type one day that holds the vector inside of it. Okay? Whee! It's like you could make a member variable that's like vector int here or something. You have other member variables as well. Like you have a vector int v, and the question is, I mean, you're hitting the constructor eventually, right? One way or another. Like maybe you hit this constructor. What if you wanted to construct v in a special way? Because you know that when you declare a vector just as normal, like as a normal vector int, I don't know. If you just say this, right, it's hitting the default constructor of vectors and making it empty. It's all coming, it's one big circle now, isn't it? There's other constructors for vector. I showed you the fill constructor. Fill it with 42, fill it with 142s or something, right? How do we do that for our v member variable? How do we construct one of our member variables with a different constructor call? Because it's way too late to do it here. It's way too late to do it here in the body. Say like v. This is just making a local variable and shadowing things, the problem from last time. It's like, how do I call the constructor on v and get it to be something I want it to be? Like, don't use the default constructor. We need this new thing, right? That's what I'm trying to say. Also, what if you had a const? This is something that you might want one day. Const like double D or something. What if you had a constant member variable? It's const. It never changes. You have to set it once. You can't set it here because you're not sure what it should be. It's too late in the body of the constructor to even set that thing. I'll get a compiler error. It's like, no, can't do it. Where could I set it then so that it never changes after I set it that one time? Again, we need this thing called an initializer list. So for both of those reasons, I have to teach you this. All right? It seems a little contrived right now, I know, but like this is useful. All right. So like, what if you wanted to construct a member variable like a vector? Use the fill constructor. What if you wanted to like initialize a const member variable that never changes? Like the constructor is where that should get its value, but we need it to give it that value in a special place. All right. So you're going to use this thing called an initializer list, and what you do is you put a colon, not a semicolon, but a colon, a single colon after the parameters of your constructor before the body. All right, so you're going to make, here's your constructor, class name, colon, colon, class name with all of its things. Then you put a colon before the body of your constructor, and you start giving constructor style calls, and these x1s are your member variable names, x1, x2 are your member variable names, and here are calls to their constructors with certain arguments. You can comma separate those things, but it's after the colon, all right? So that's a little weird, but that's the secret. So the secret is to include the little sad face. Do you see the sad face? That's the secret. That's your initializer list, all right? So look for the sad face. You'll never forget now. Look for the sad face. And x1 and x2, those are the names of your member variables, and then these are like arguments that you're passing along to their constructors, all right? That's the secret. You do that before the body. So it's not horrible if I do it for you. I'll show you. It's not going to do anything horrible. But you can actually set any member variable like this. You can always use this constructor style syntax, actually, even for an int. Like if we were going to set our int, like if we had a member variable called x, like instead of this, there is a way to make it look like a constructor call, even if you're going to initialize like an int or something normal. You can do this. This works in C++, int x 42, like a constructor. That's kind of cool. So we can do initializer list for every single one of our member variables, and that's usually what people do. All right, that's a good idea. Let us implement it. So, like I was saying, instead of setting count, even setting count here, like you could have done it in the initializer list. Let's give a colon, And then we're going to give constructor-style calls to everything we'd like to initialize right now. So I'd like to initialize count to 0. All right, it's always your member variable name. Give a constructor parameter. So even for ints, you can do that. It's fine. Then you comma separate the other ones. Like if I want to use the fill constructor on the vector v, be like v, I want it to hold 142s. That's how you do that. All right, that's how you set it. And then same for your double constant member variable. You can set it, and it will never change after you set it. The only place you're allowed to set is the initializer list. So it can just be like D3.14, and that's allowed. Okay. Now you don't need this line anymore. All right. Does that make enough sense? It's a little weird, I know, but this gets run first. Like as your object is being made, before it even runs the body of your constructor, it does all the things in the initializer list from left to right, sets count to 0, calls that particular constructor for vector v, sets that const double to 4, and then it runs the body. So technically, if you don't want to print anything, you can have an empty body, and that's totally fine, and maybe preferred. Okay. So that's that one. And then I got to do the same. Let's do the same pattern here in our parameterized constructor. Colon, set the count to the starting count, just like that. So I don't need this line anymore. All right, then we can do the same for like, maybe we want the vector to be empty when we use this constructor. So we'll just not talk about the vector. And like we can give 3.14 to the, okay? That's fine. Everything that you don't touch gets default constructed. Every one of your member variables, all right? So that's the secret, that's the trick. So this is your initializer list. Let's see. It's the best way. Boop. I'll make this pretty. So that right there is your initializer list. All right. That's how it begins, and that's how you call those things. So now it will compile and run, and there's no difference because I'm not using those new member variables, but the count is still getting initialized to the right stuff in each constructor, right? Nothing has changed. Question? Yeah, if you omit it, it's just as if you like you didn't want anything special, so it will default construct the vector. Including D, what do you mean? Oh, I see what you're saying. You don't get both. You can only call one constructor. No, you can't run multiple. And so if you want, you need to set D if it's a constant, like it will give you a compiler error if you don't set it. So even if you want to set it to 3.14 always, you have to put it in both constructors because you can only call one. Like this is only calling the default constructor. Every one of your member variables gets made. The question is, how does it get constructed? Which constructor of that member variable gets called? Because we're always making a v. Every one of our member variables, we're always having a count, a v, and a d inside of every object that we make now because I declared it like that. Now the question is, what should their values be at the start? Do you want to call a special constructor on vectors, or do you just want it to be empty? If you want to do it this way, you got to do it like that. If you want the vector to start out empty, by default, it will be default constructed. This is definitely a complicated topic. I think you'll read about it a little bit in your book too, but yeah, it takes a while to sink in. I'll just say that. Any other questions? But yeah, at the very least, like all I really care about you understanding is that like, let's get rid of these extra member variables because they don't even make sense for this class. Like that's the reason the initializer list is necessary. But you can still use it for your member variables, like just for your count. You could do it like that, right? And so I'll get rid of that one, get rid of that one. So I'm still initializing count to something, right? Using the initializer list, and nothing has changed. All right, so that's the secret. A bit of an advanced topic, but a useful one. You'll study it more in CSCI 41 for sure. All right, so if we are I have a question for you. So I'd like you to try this. You can break open the server if you want. You don't have to post it anywhere, but I want you to just think about it at least. I've been using the counter class, right, all day long. Let's do a different class. Think about the point class that we had before, right, that held two-dimensional points. So I'd like you to think about that class from last time. You can go back to the code from class if you'd like, copy it. But like we had a class point, right? Class point, and it held stuff, right? Among other things, it had like a private like double x and y, right? Every point needed an x and y coordinate. And so what I'd like you to do is like make a constructor for points. So you can declare a point and give it an x and a y coordinate all at once. Wouldn't that be nice? That will make your p object and set the x to 3.5 and set the y to 4.7. And yeah, remember how to do an initializer list. It's this idea right here. It's going to be point, colon, colon, point this time, won't it? See that? All right. And that is what I want you to think about for a few minutes. So go steal my code from last time, probably, I don't know, if I'm currently in the lecture 16 folders, either in 15 or 14, go find point from before and tack on a constructor, all right? Constructor and use initializer lists, this idea, to initialize the x and the y to those values, okay? Give it a try. How we learn. I'll give you a few minutes to think about it. And then also I use the header file as well, so you'll have to go touch the header file as well. This is not you just go inside the body of your constructor. And I'll draw it in like a couple minutes. I'll draw my answer. The name of the constructor will be point, not counter, because this class is called point this time. Oops, sorry. Obviously, everything else is public. that is my little timer. I'm going to give the answer away now. Are there any questions that came up as we were trying it? Did we forget any syntax that I could help with, that I could say something about? We can talk philosophy if you'd like as well. But this is called point. This class is called point. So if I want to say this is going to be a parameterized constructor. It takes two things, also called point. So let's declare it, and then we'll implement it outside the class, just like I did for the other one. Point, and we're going to give two things. A double value that we want to put in our x. You could call it x if you wanted, but and it won't work with the initializer list, so it'll just look a little odd. So I'll just say double x val, double y val. Now it's getting two things, so it's going to call that one, and now I just need to implement it. What do I do when that gets called? Let's section this off, and I'll implement it over here. Hopefully there's enough room for it. So I'll say it's going to be points, colon, point, right? Then it was double x val, comma, double y val. Let me recycle that. Better. Double y val. Colon, right? Colon, and then give constructor style initializations for our member variables. So we have a member variable called x and y. We got x. Set that to x val. I'll just do it over here even. Set x to x val. That will work. Set y to y val. All right? And then that's it. Like, you still have to have a body for your constructor, but it can be empty for our case. We've done all that we need to do in the initializer list. Okay. So that would be the answer. Are there any questions about why that would be the answer? It'll look like that. Obviously, you'll probably make it look prettier, but like those are the things that you will type. Cool. All right. So, is there anything else I want to show you about this file for now? Not yet. Okay. So if we're good, I just want to kind of talk about the colon some more, because like classes, you have to say this. It's points, point method. It's not a function. It's something special, right? It's counters inc method. It's not just like a normal function that exists outside of everything. It's kind of how you tell C++ that. But there's more to it. Like there's a concept of ownership, right? It's counter owns the inc, right? The inc method. It's counters inc method. I kind of told you to say, think of this as like an apostrophe s. So like there's more to that. Let's talk about it. It's called namespaces, right? You've actually used that word already. You're using it all day long. I just never told you what it meant, right? Using namespace standard. We say that all day long. What does that really mean? All right. So first of all, every class gets its own thing called a namespace. All right. So this has to do with the colon. So like every class gets its own thing called a namespace. And so like that's a space where you could put names, which is kind of self-explanatory in theory. It's like you have a counter class, and that makes a counter namespace, and you can put stuff in it. Like every counter, it has an inc inside of it. It has a count inside of its namespace, we say. And the whole point, and the way to like get out the one you want is like counter colon inc, counter colon count, whatever. That colon is called the scope resolution operator. If you ever wanted to know, now you know. All right. And the whole goal of having a namespace is the fact that you can have two things with the same name and have them not clash if they're in separate namespaces. Like you can make another counter class that works slightly differently, call it counter2, and it gets its own namespace. So you can also make an inc inside of it. You can also make a count member variable inside of it. Yeah, that's the goal. So, and they don't clash, because you know if you make two variables called x, you say int x semicolon twice, the compiler will complain. It's like, which one? I don't know what you're talking about. You can have two things in the same namespace, but you can have them in separate namespaces with the same name. That's the goal. So namespaces is the whole point of namespaces. I'll use a different color to emphasize this, so that you can have two things with the same name and they don't clash. All right. So I'll give you an example of that. You can just, outside of classes, you can also make namespaces where things can live. All right. I want to show that to you now. And this is what's going on in the standard library, by the way. They made a namespace called standard, std, and that's where they put everything, so that you can make your own thing called vector. because it's not in that anymore. You just wouldn't use namespace standard at that point. Does that make sense? You can make your own thing called vector. You can make your own thing called cout even if you wanted to. Just don't include the namespace standard. You have to qualify it at that point. Right? That's why they did it that way. So namespaces.cpp, and I'm going to make 2 separate namespaces with just some functions in it. 2 functions called blah and 2 global variables called x, just to keep it easy. So here's one blah function. It will return 42. And then here's a global variable called x. It will hold 55. Oops, 55. And then here is a completely different blah function that returns, I don't know, 13. And here's a completely different x global variable that holds 33. And right now, this is not going to compile, right? It's called namespaces.cpp. It's like, excuse me, you are redefining blah and x, and I can only have one in scope at once, so I have no clue which one you wanted, so you can't do it like this. Right? So it's not even going to compile right now, but I will make it compile if I make some clouds. I'll make my own namespaces, 2 different namespaces so that we can qualify which one we wanted, all right? So this is how you make your own namespace from scratch. You say namespace, and just give it some random identifier, like n1 is a namespace. And you can put whatever you want to live inside of n1 inside of its curly braces. So namespace n1 has that, these things, and then namespace. You could also just use, like, it will compile at this point, because like this is the default namespaces blah, this is the n1 namespaces blah. That's fine. You could also do it like this. Make another namespace, n2. And now we have no clashes. And now it will compile because this is n1's. This is n1's 50x. This is n2's blah. This is n2's x. There's no issue anymore. Like, you know which one you're talking about because now you can qualify it with the colon. All right. So here's how you use these. Let's split screen down here in main. If I want one of them, like, I just have to say this. All right. Cout. I can't just say blah right now. There's no default namespaces blah. But I can say I want n1's blah. Call that. See that? I would like n1's x, please. Print that. Right? And then same for n2. There's no issue. There's no confusion. Oops. I don't know how I just did that. Impressive. N2's blah. N2's x. And now it will compile, it will run, it will do exactly what you think it will do. Cool. So I get my 42. There's that one. There's that one. 42, 55, 30, 13, 33. Cool. So that's what namespaces are. And classes make a namespace for you. So that you can have, that's where your methods live. All right? But you can make one yourself. And so secretly, deep down, when you include anything from the standard library, like if you go and look at the file that's being included and copied and pasted, it starts like this. They say namespace standard, and then they define everything inside of that. All right? That's what they did. And so if you just want to like import everything, you use this using thing, using namespace standard. Like so it does it for you. All right? So that is one less secret now, or one less magical thing. You know the secret. All right. So yeah, I hope that makes a little bit of sense. Yell at me if it does not, but like technically classes, you can get most of the way towards a class by like you make your own version of a class without using C++'s class keyword by just making a bunch of namespaces, like make a namespace called counter and like a struct that holds what you need and like functions inside of that namespace that like have the secret 0th parameter like actually explicitly there. Like there's a way, okay? But that's as far as I want to go right now. Any questions about namespaces? That's why you need the colon, right? That's kind of why I'm explaining this right now. Like, that's why this exists. It's like go inside the counter's namespace. We're defining the counter method. Right? Go inside the counter's namespace. We're defining the reset method. That's secretly what's happening. All right. If we are good, I have one last trick for you. All right. Wouldn't it be nice if we could add 2 counters? I could say this C1 plus C2 and have it mean something. Super cool. So right now we don't have that. Like the best what we could do is like make an add method like c1.add c2. And if you use Java, this is as good as you can do. They don't have this thing, which is sad. This is the greatest thing ever. So instead of something like this, which is, I mean, respectable but ugly, we could have this. All right, and here's how you do it. If you ever say this and you have two things of your own class's type, like counters, let's say, and you say C1 plus C2 or C1 and C2 are both counters, what C++ will do is it will secretly try to translate this into either this call, C1 dot, a fancy method called operator plus C2. It'll go and look for that, or it will go and look for just a normal function, also called operator plus, that will accept two counters C1 and C2. Okay, it's going to try to call one of these. Only one has to exist. So just like make the one you feel like making, make it as a method, or make your operator plus as a function. It's going to go looking for that. All right, it's a special thing called operator plus. That's what plus translates into secretly under the hood. Is that a question? Yeah. That's a great question. I've actually never tried that. Let's try it. We'll try it together right now. All right? But it's just going to use whichever one exists. And as long as we want C++ to be able to add counters using the plus operator, like we just have to give one implementation of operator plus, either as a method, so it just takes one thing and gets ourself implicitly, or it takes two things, both counters, and so it's not a method, it's just a function, right? So I'll show you both. And so first of all, let's think about like what should it mean to add two counters. Like I think the idea, if you say like C plus D or something, we got our two counters, and we want to, like, it should give back a third counter first of all, right? Counter sum. I think that's useful. That's a good thing to have. And so I think what we should just do is add up the counts, right? That would make sense to me. So like our counter sees if its count was, I don't know, this count was 3, and if D's count was 4, I would say that a reasonable implementation for the plus operator would be to make a brand new counter object called whatever and return it, and then we can shove that into sum, and that will hold a count of 7, right? Summed count. I think that would make the most sense to me. So let's do both of these. I don't know, we'll see which one gets priority. It might just give a compiler error. That's my guess right now, but you never know. But let's say it's going to go looking for one or the other. All right, so let's pretend to call it first. I think that will be the most useful thing. So let me also section off this, like new idea. Time for a new idea. So I want to do something like this. Counter sum equals C plus D, right? So what will happen is C++ tries to call C to operator plus with D, or it'll try to call operator plus a function with C and D, right? It's going to do one or the other. And just for fun, we're going to give both and see what happens. Let's do it the first way. Let's do it as the method way. So like if it was a method, it would be a method on the counter class, and it would take one thing. It's called operator plus. It takes one thing, returns a counter. Right? That's what it would look like. So let's put that up here, a public thing inside of the counter class. Put it right here. There's the start of it. And we'll say it's operator plus, and it gives back a third counter. It takes ourselves and somebody else, counter other. And we just want to look inside of that other counter, right? So let's get it by reference and as a const reference as well, all right? And then also, this method should just be looking at our own member variable too. It's making a brand new counter with a certain count. Looking at the other things, not touching it. It should also just be looking at our count and not touching it. So it should also be a const method. It's a little funky. All right? So that's that one. Let's implement it. So that's going to be called by C++. All right? I guess I'll just put them all down here. There. So it's a method, so it's counters operator plus. And so this is a little ugly, I know. So here, let me split screen it this way so you can see where I'm using it. So again, what's going to happen when we get here, it's going to try to call one of these two. If we make it the method like this, it's going to say C dot operator plus with D. So we're jumping up here. Our own object is C. The other thing is D. All right, so I want to make a third counter. Results and fill results count. I could have used the constructor if I wanted to, but I'm just going to be lazy. It's that results count should be our own counts, right, which is C's count in this case, plus others count, which is D's count. All right, then return that. All right, that's going to work. That's going to do it. And I don't want to do that. Weird little split screen going on right now, but I hope you get the idea. It's going to jump up there. It's going to work. It's going to be great. And now it's only pressing A. Oh no. We had this problem before, didn't we? My computer thinks that shift is being held. Oh no. Oh no. Okay, cool. We're back. We're back. No, we're not. Let's see. What's the best way to fix this? Do we think it's just that app? No, I think it's like control is being pressed or something. All right. I think I fixed it somehow once upon a time. Do you guys remember what I did? Did I unplug stuff? Did I do this? You have a question? Oh, that's right. Thank you. Yeah, it was Control Alt Delete, wasn't it? Thank you. That's what I'll do. Just a second. Once it gets back to normal. It's funny that that does it. Like, I don't know what happens when this happens, but cool. Are we back to normal? Yeah. Thank you. Thank you very much. Just keep on saying that if that ever happens again. I appreciate it. All right. So in theory, I can press enter and it's happy now. Cool. And now, finally, you get to see the usefulness. So we're default constructing this just to change the count later. It's a little lazy, but that's okay. All right. And so we hit up here. And then we return our count of 77, which is apparently 34 plus 43, which does make sense. All right. So that's the start of it. All right. Are there any questions before I try to mess up? Make a second thing called operator plus. So you could either do it this way, or you could make a function that just takes two counters, just not part of any classes or anything. All right. So let's do that way. That way is going to look a little different. This would have been operator plus. It would have been. It's just a function called operator plus that takes two counters. So const counter reference C1, const counter reference C2. Again, it's doing kind of the same thing. It's C1's count plus C2's count. And so it'll also it might also call this one, right? This is your other option. You could have implemented it like this. I guess you can't do it this way because we're not inside of a class anymore. We can't do the dot. So we could do this. We could do initialize. New the constructor. There you go. That'll work. Oh, sorry, but now it has to be .get count. You see the problem. It gets a bit harder when you're doing outside of a class now. But in theory, that would also work. All right, you could do it one way or another. No, other kind of split screen. So again, this is either gonna this syntax is either gonna try to call this one, C.operator plus, or this one. And here's that second one. Takes two counters, it's called operator plus, it returns a third counter. Alright? I think it's about to give me a compiler error, which makes the most sense to me. Perfect. Yes. Yay. Cool. So you cannot have both. You cannot have both. Also, sorry, excuse me. One last error. One last error. I can't say const here because it's not a method. I don't think that's going to be the main issue, though. Let's do this. Cool. All right. It says these are ambiguous, even though the worst conversion for the first is better than the word, whatever. So, all right. It's I can either call this one or this one, and oh my gosh, it was a warning. It actually compiled. So, let's see here. We still don't know which one's going to get called, and we can't tell right now. So it actually compiled, which is very surprising to me. And let's figure out which one this particular compiler preferred. We see out option 1. Option 2. You should never do this. You have no control. It's going to be random. But it compiled, and it chose option 2. It chose the function one. Crazy. Well, yeah, that's all I wanted to say about that, I think. But you can give one or the other, all right? You should only ever give one. That was a great question. Now we know. So just for posterity, we'll put this out here. Don't need this anymore. And so now we're back to normal. Just calling that one that we know and love. All right, so that's that. All right. So if we're good, let's talk about other operators. You can overload pretty much every operator that ever existed. It's very cool like that. Let's see here. So I'll do plus plus, like instead of increment c.inc, like we make it faster, c++. That'd be cool. And then we'll also do like a less than operator so that we can compare our counters. Right now we can't do any of that, all right? But you can look up, there's a big page with every operator under the sun. Like you can overload all these bad boys. Ampersand operator. You could even overload like the plus equals operator. That would work. Isn't that cool? Like all these exist. There's plenty more down here probably. A whole long list of them. You can overload any of them. All right. Overload the function call operator, which is a little disgusting, but that's the thing. So think about it, look into it, but I'm going to give you two more examples. We'll do a plus plus and then a less than. I'll do plus plus inside the class, and then I'll do less than outside. All right. So like here's what I want to be able to do. Instead of calling like something.inc, instead of saying sum.inc, instead of that, wouldn't it be cool like to have another option to do like sum plus plus? I'm actually going to show you how to do the operator that's the prefix one. I'm going to do plus plus sum. Sum plus plus is slightly more like complicated for a silly reason. So I'm going to do it this way. Right? I'm going to implement this prefix plus plus operator. And this will be, again, it'll try to find a function or a method called operator plus plus. Let's just do it as a method again. We'll do like, it'll call sum dot operator plus plus essentially. That's what's about to happen. So let's just go and implement that, right? Let's do it. So up here, I'll declare that it exists, operator plus, and it's going to be void, right? Void operator plus plus takes nothing, and it's definitely not const because it's changing stuff. All right, so there's that one. So that's what it's going to look like if it's if it's a method. You could have made it a function too, and then I'll implement it down here. And so it's a method, so it's counters operator plus plus. And what should it do? It's just increment the count if you ever get called. All right, so there I am calling it plus plus sum. It's jumping up to here. It found operator plus plus and it's happy. All right. There we go. So it made it. It was 77. It made it 78, and I should probably print out that 78 to prove it to you. There it is. Right? That's kind of neat. Like we can overload any operator. Like if you want to have a plus plus for your object, make a plus plus. Tell it what it means. All right? You just have to give meaning to it somehow. And yeah, for my last trick, let's do less than operator. Operator less than, right? Because like, wouldn't it be nice again if we had like we could make a vector of counters. We could do that if we wanted to. We can put a bunch of counters in a vector. And we can ask C++ to sort that vector. We just have to give meaning to like when should one count come before another. Isn't that cool? So like I can do this. I can say, I can make a vector of counters. All right, a vector of counters. Call it v, and it can hold stuff like sum. It can hold c and d and all those things. And then let's say I want to sort this vector. Wouldn't that be cool too? Like sum holds count 78, c holds count 43, d holds count 34, so it's not really sorted right now. Let's say we want to sort it by the count maybe. We could include algorithm and be like, hey vector, sort yourself. Sort v.begin from v.begin to v.end, and it's just not going to compile right now because C++ doesn't know how to sort the type that we just made out of thin air. Like it's like I have no clue what counter means. I don't know when one comes before another. So it's going to give you a very long error message to that effect, and it's going to talk about something that you understand. It's going to say operator less than. What it's doing is it's saying, I don't know how to figure out when one counter comes before another. I'm listing out all the ways that I know how to compare things. Like I know how to do this. Like Like I know, like I'm looking for something that's operator less than on counters. I don't see one, but we can give one. And then it will use that to sort, because then it knows like when one counter comes before another. We just have to give meaning to like when is one less than the other. So here, sort will call operator less than. All right, and so it'll try and like check, hey, is C less than D or something? And then as long as we make a function, right, that returns true when it is and false when it isn't, it can use that for sorting purposes. So C less than D turns into either. This will be happening under the hood in the sort implementation. It turns into either C dot operator less than with D, or again, operator less than the function call on both C and D. And let's just do it this way. Let's do it the function call way, because I've been preferring the method way up until now. All right, so let's do that. Let's make an operator less than that takes two counters and returns true if the first one's less than the second, false otherwise. Let's give meaning to having a counter like less than another. Right? So it's operator less than, it takes two counters, counter A, counter B. Let's take them by constant reference, because we're just looking at their values. Const counter reference B. Because the whole job of the less than operator is like, is it less than true? Is it not? False. So we essentially just want to go in and get the count out of A and the count out of B, because that's what we can use to sort, right? Let's say that a counter A is less than counter B if A's count is less than B's count. I gotta use get count because this is just a function. I can't like say dot count anymore. So I don't have access to that. It's a private thing. And this is outside of the counter class. All right. Bless you. So there's that one, and it's gonna compile now. I'm still calling sort, and it is happy with that. All right, let's actually see the fruits of our labor though. So I put in this vector, some had the biggest count, then C had the next biggest, then D had the smallest count. So it's kind of backwards. It's going to sort it from smallest to biggest now. After this is done, and so let's go through for every counter, call it CTR, in the vector V. Let's go and look at that counter's count. See out CTR.getCount. Then we'll just like space separate them. So we'll see that the vector has changed. All right. So that'll be it right there. And we'll see counts in ascending order. Beautiful. And it definitely didn't start like sum was the one, right? Sum is now the last thing instead of the first thing. It did it right. So the second we said sort, like it was checking. It had a big long loop that was checking things. And it eventually jumped up here like, all right, I got two things to compare, two counters. Tell me when one comes before the other. I'll put it sooner in the vector for you, right? And this was the way. So that is, I think, the last thing I want to blow your mind with today. Are there any questions about that? So operators, yeah. That's true. I know there's a new C++. Yeah, you can. You totally can. There's like a C++ version, language version 2020 edition way to do it with like, there is like an import operator. There's modules in that version of C++. But I don't actually know how to do it in an earlier version. Declan, do you? How do I import just sort? Is there a way? I don't think there is. Yeah. Nice. Yeah, so they're thinking about there is a way, but it's not ready yet. What could we do? Actually, wait a second. I think using could be done for that. C++ using. Or is that where the new keyword's coming from? Let me try this. What's the easiest way to try it? I think like this should work. Like this is what I'm thinking about, using standard sorts or something. Is that a thing? Is that a thing? What else am I using? Cout. Yeah. Yeah, there we go. There we go. So now it's happy. That's a thing. Oh, vector. Using standard vector. Oops. oh gosh, what else? Indel. So if you just want to pick them out, they're going to make it easier on you, but I think this is a thing. That's a great question. Yeah. And now if you say something else, like CN, right? Yeah. Index, CN index. I don't know. Did you mean standard : CN? Nice. That's a great question. I had no idea. I pulled that out of some corner of my brain, so thank you for that. Let's forget about that though. So you can say using whatever you want. Nice. But they're about to make it easier. That's a great question. Any other questions? All right. I think that's it for classes. That's as much as I want to teach you about classes. There's a lot. It's 3 lectures worth of information. But we made it, and that will be it for the day. No assignments this time, or next time actually.